continue on with our notes. Okay, so at this moment in time, we have two formulas available to us. Now, there are other formulas that we are going to be required to use. Yes, these are the two that you're required to know. All right, hopefully you'll have these known. And we'll talk about these other ones, but not yet. Right now we're doing these. So, quick recap. Who remembers how I know when to use what? What's the deal? Anya?
The first one is for compound interest.
Compound interest. When it's compounded a specific number of times a year, like compounded monthly, compounded daily. What is this one, Anya?
Continuous growth.
If it says compounded continuously, then we're gonna use this one. If the word continuously is in it, we're gonna use it. When else do we use this? Oh, maybe we haven't done one yet. We use this when it's not money. So we'll have problems that aren't money. This will be the formula you will use, period. Even the new ones I give you, they're about money. So this will always be our formula if it's not a money problem, okay? Did we do number 3 yesterday?
Yeah.
Yeah. Did we use this formula right here?
Yeah.
Because that was not money, right? Okay. All right, what about number 4 now? We're ready for number 4. Which formula am I going to use? Read it. PERT. Underline compounded continuously. And the problem, that's your clue that you're going to use PERT. Do we have an A? 35,000. What does A stand for? In both formulas, A is what I end up with, right? Do I have a P? Nope. Do I have an interest rate? It is 0.04. I remember always that when I put an interest rate, a percentage into the problem, it goes into the decimal. Do I have a time? 10? Now, I like to, when I have a double exponent like this, I like to just clean that up right away. So that's going to be 0.4. So 35,000 equals PE to the 0.4.
I thought you just said we didn't use PERT for money.
We use PERT for money if it's compounded continuously. Okay, Peter? All right. Now, my job is to solve for P. Am I going to use logarithms? No. The only time I need logarithms is when my variable is up here or up here. If your X, your unknown, is up there, then you're going to have to use logarithms. If it isn't up there, then don't use logarithms. So how am I going to get P by itself? I need to solve for P. How am I going to do that? Divide by e to the 0.4. So 35,000 divided by second ln is how you get E. Look at your ln button right above it, it's E. So 35,000 divided by second ln 0.4. And hopefully you got $23,461.20. If you need E, it's second ln. That's how you get the E button, or the E on your calculator. Everybody okay? All right, let's see what we got. Find the decay constant of an element if its half-life is 10.2 years. Well, first of all, what formula? PERT. It's not money, so it has to be PERT. What does half-life mean?
When something will disintegrate.
Well, you got something disintegrating and decaying, and half-life is the time it takes for half of it to decay. So if you started with 10 grams, and in 15 years you had 5 grams, then your half-life is 15 years. And then after 15 more years, you'd have 2.5 grams, and then 1.25 grams, and so on. You lose half each time. Did they tell me how much I'm starting with? No, they didn't. But what do I know? I know that whatever I start with, I'm gonna end up with half of it left. So if I start with, I don't know, pick a number, 100. If I start with 100, then I'll end up with 50 in a half-life situation. Now, I know some of you are a little uneasy because you're like, Ms. Ford, can you just make up numbers? Wait, watch. You're gonna see. You can't. You actually can in this problem. So I'm starting with 100, ending with 50. I don't know R, that's what I'm looking for, but I know that the time is 10.2 years. Now, assuming I'm allowed to make up these, no, this one's made up. This one's half of this one. Are you okay with my setup there? What's step 1? Divide by 100. You've got to divide first. Now, what's going to happen when I divide by 100 is this is going to be 1/2. Now, I want you to think about something for a minute. Maybe you didn't want to start with 100. Maybe you wanted to start with, I don't know, 30. Well, if you started with 30, wouldn't you end up with 15? You're going to divide by 30. Is it going to matter in the end? No. So if they don't give you a starting point, that's okay. Make one up and then end with half of it, if it's a half-life problem.
Wait, but if it's a half-life problem, can you just automatically go to like 0.5 or 1/2 equals e to the
Absolutely.
r2?
Yep. So Katie's saying, what if I just skip this part altogether because I know this is what's going to happen? Absolutely. Start with 1, end up with 1/2. Isn't that what you got? Sure can. Absolutely can. This is the equation we're going to solve right here. Now notice where the exponent is. Excuse me, where the variable is. The variable's up here. So I'm going to ln both sides. Take the natural logarithm of both sides. This will disappear. ln cancels when they touch. So ln 0.5 equals 10.2r. So what's r? ln 0.5 over 10.2. Would you agree? You're all typing in. I'm assuming that's what you're typing in, hopefully. ln 0.5 divided by 10.2.
Pardon the interruption. We need the following students to come to the admissions office: Sammy Bridges, Will McCormick, Tommy Davey, Braden Beasley, Dave Bragg, Caleb Martin, and Aiden Stahey. Please come to the admissions office. Thank you.
Okay. Here we go. What did you end up with? I got negative 0.0680. Now I'm randomly rounding it off. It didn't tell me how, but did you get something that looks like that? Okay. Why in the world is that negative? That, in this formula, this is my growth constant. It's like the interest rate. Why in the world is it negative? Because it's decaying, and decay is negative growth. Now, would you ever want that to happen in a money problem? No, because that would mean your investment was going down, right? But certainly, if you're decaying, your growth constant's gonna be negative. All right, next, which formula? Number 6, here we go.
Can we, is that answer just that, or do we have to put in a percent or anything?
It says find the decay constant,
Okay.
so that would be the constant. Now, if this was a money problem, and it said what's the interest rate, then you would turn it into a percentage. All right, which formula for number 6? That's a perk. It isn't money, so it's a perk. We got 193 of them, growing into 391 of them. And the constant is 0.222, and we wanna know how long it takes. Everybody okay? What's step 1? Divide. Now, some of you are very uncomfortable leaving things like this. If you type this in, it isn't gonna go in evenly. It's not like 1/2. It isn't gonna go in evenly. And then if you round it off, remember, we're still gonna be LNing it, right? So then you're gonna have even more round off error. So just leave it like this, so that we don't end up with a bunch of round off error. I will count off for unnecessary round off error. So just leave it as a nice little fraction. And then ln that and divide by, divide by 0.222. Did you get 3.18? I guess it doesn't tell me. Let me see years. It's a time, months, days, something. Is that what you got? All right, would you try 7 and 8 on your own? 7 and 8, would you try those on your own? And then, if you feel confident, I'll have you come up and put them on the board for us. 7 and 8. So first of all, you're gonna figure out which formula you're gonna use, and then you're gonna plug the numbers in. And I'm gonna do attendance. So Eli's out. Great. Only 2 absent today? That's awesome. Okay, volunteers, anybody ready to put one up there? Come on, if nobody comes up, you gotta listen to me. You guys together, or you
I'll do
each?
8. He can do
I just don't have, my calculator's charging, but, you know.
You can use mine, it's right there. Okay, here's one marker. Yeah, we need
Oh, I gotta
this.
come over here, don't I?
Yeah, come over here, yeah.
Would you come with me?
Alright, I'll go.
Yeah, as long as that's a dark purple, it'll show up, okay? All right, here we go. We're gonna check your answers with theirs. Number 7, did you notice as you were doing it, there's no math to do, don't you just type it in? Those are our favorite kind, we don't have to divide, we don't have to do anything, we just type it in and hopefully get the answer that Jake says. Now Katie's is a little bit more involved. Did you divide by 890 first? Then did you LM both sides? And then divide it. So hopefully,
Your calculator, do I need to put like those parentheses inside of the parentheses? I just need to hit divide.
you should get 844.17. And you should get, yeah, you want to write that as a percent, it says what interest rate, so that'd be 3.8%.
Right, okay.
You said like
0.17, yeah, $844, is that not what you got?
yeah, I just don't know. You can calculate it.
Okay. Little calculator discrimination going on there,
Oh, alright.
because mine's not as new as
That was-
yours.
I just don't know how to.
This is Ford, you don't need to get one bricks.
Ford, it's not my
We just
fault.
have to use furniture bills, we don't need bricks necessarily.
These are little calculators. All right, these are the answers that I got. Katie, if we're gonna say that, I would say either 3.9 or 3.88,
Okay.
okay? So, since, oh, someone left the pencil up here.
I think that's fine.
Since the last problem asked for an interest rate, we're gonna write that the way they write interest rates, and that is as a percentage. Is everybody okay with their strategies? Now, Katie didn't really show what she did here. Once she divided, she natural logged both sides, so ln 1,000 over 890 is 3R. So then she just took this guy right here and divided him by 3. And that's how she got this answer. That is correct answer. Okay? Anybody have a question about why they chose the formulas they chose? Alright, now guys, we're gonna look at some different formulas. And you don't have to memorize them. If I want you to use them, I'll give them to you, just like I did here in the notes. But you have to know how to use them, alright? So let's talk about what is different about these two formulas. How do I know when I read a problem whether I'm gonna use one of my two old formulas or if I'm gonna use one of these new ones? Here is the key. Let's read problem number 9. Carlos purchases a new pickup truck. What are the monthly payments? If you think about it, now these are money situations, so let's think about the money situations we've done so far. In this problem right here, did this person make payments? No, this guy walked out to the bank, handed him $555 and came back 12 years later. There wasn't any regular, investment going on. It was a one-time shop. And that's how it's been with all of our problems. If you're in a money situation and it's a one-time deal, then these are your formulas, period. But if you are making payments, and there's two ways that you can make payments if you think about it. You can pay off your car, or you can pay off your mortgage. Many of your parents are making monthly mortgage payments. They're paying off your house that you live in. Monthly payments. Maybe you have a credit card bill. I hope you don't. Credit card bills are bad. But if you have a credit card bill, you're making monthly payments on that bill. Credit card bills are bad if you're not paying the balance off every month. If you're, as long as you're paying the balance off, it's good. But not if you're carrying the balance at 20% interest. Crazy. So one way to make payments is to pay a bill, to pay off something, pay off a student loan, pay off a truck, pay off a house. Another way to make regular payments is what your parents probably have done your entire life. They're saving for your college, or they're saving for their retirement. So every month or week or however, whenever they do it, they set aside a certain amount of money. They do it regularly, saving for the future. So we can make payments to pay something off that we owe right now. That's called present value. When I make payments to pay something off that I owe right now, my car, my house, that is present value. I use the present value formula. If I am saving for a future event, my retirement, your college, my grandchildren's college, that is future value. Making payments is going to be PV or FV. What you're making the payments for is how you determine which one it is. Paying off a loan is PV. You owe it right now, you're paying it off. Saving for the future is FV. Okay, got it? All right, how do these things work? Here we go. Question number 1. He bought a truck. We want to know what the monthly payments are to pay off this truck. So this is going to be a PV problem. So my PV formula looks like this. All right, so I'm paying off a loan, it's PV. In this formula, and FV, they have the same letters. They look very, very similar. This is the amount of the payment. So R is the payment amount. In both formulas, R is the payment amount. Now, I, you might guess, stands for the interest rate, but this is a little bit different because the interest rate is not just, what is his? His is 2.9%. So what I put in for the interest rate is 0.029 divided by 12. Now, why do you think I had to divide it by 12? Meg?
Because you're splitting up an annual interest rate into 12 months.
Exactly. Exactly. It's splitting up into months. So it's getting divided by 12. Very good, Meg. And that's the same thing that goes on the bottom, 0.029 divided by 12. Now, what is this N? The N in both formulas is the total number of payments the guy is going to make. So look at it. It's a 4-year loan, and he's making monthly payments. So what's his N? 48. 48, and it's negative in this formula, negative 48. So in these formulas, N is the total number of payments over the duration of the loan. So if you have a 30-year mortgage, which many people do, then your N would be 30 times 12. A big number, 360, big number. Okay. Now, this is the present value of the loan. This is how much money you owe. Be careful, I don't know if you've ever done this kind of thing or not, but the truck cost $18,500, but he put $2,000 down. So what is his loan actually? It's not $18,500, it's $16,500, right? So his loan is $16,500. Because the down payment is paid off, he doesn't have to owe that anymore.
Make my own patterns.
Now, wow, the worst part about these formulas is getting this typed in. Before we start, I want you to think about what you're gonna be doing. Are you gonna need logarithms? No, this is a straight type in. We only need logarithms if we have a variable up here somewhere. Would you agree that this big conglomeration here is a number?
Yeah.
And to get R by itself, we're just gonna take this divided by whatever that number is. So let's go ahead and figure out what that number is. I'm just gonna do this right here. Now, for those of you that are, go ahead and do it. If you have a question, type what I tell you and we'll get it. I like to type in the numerator first. So 1 minus parentheses, 1 plus 0.029 divided by 12, close parentheses, raised to the negative 48 equals. Did you get 0.109? For your numerator, just the numerator? Okay, so now I gotta take that and divide it by this. But since this is a fraction, I have to put in parentheses. So divided by parentheses 0.029 divided by 12. Did you get 45? Did anyone get 45? Okay, so now we gotta take this number and divide it by this number. So 16,500 divided by second answer. So 16,500 divided by the last answer I got. And his payments are $364.49. So every month he's gonna pay $364.49. Alright, let's try the next one. At the end of each quarter, Emily makes a $500 payment. Stop right there. On test day, these problems are all mixed up. You're not gonna know which formula to use, but as soon as you see makes a $500 payment every month, that's FD or PV. Payments are those formulas. Investments earn this much interest, compounded quarterly. What will be the value of Emily's annuity in 20 years? All right, FB or PV? F, she's saving for the future. So FB is, I do not have these formulas memorized. Everything stands for the same thing it did before. Nothing's any different. So Emily makes a $500 payment. So remember, R is the payment amount. The investments earn an interest rate of 0.0788. Compounded quarterly, she's making quarterly payments. So we're gonna divide by 4 this time. How many is she making? Well, she makes 4 a year for 20 years, so she's making 80 of them. This time, there's no division involved, we're just gonna take whatever we get here and multiply it by 500. So parentheses, 1 plus 0.0788 divided by 4, close parentheses, 2 to 80th, equals minus 1 equals divided by parentheses, 0.0788 divided by 4, times 500. That's what I got, but I did that kind of fast. So who knows? Tell me if you got that, somebody. I'll type it back down for you too. Anybody else get that? Nope. Hurry up. By the way, that's another thing for these, drills that we have in the real thing. If you happen to be outside the classroom, you cannot get back in. So they'll help you figure out where you need to go, but once that door is shut, we're not opening it for anybody. Wish you wouldn't leave the room. All right, nobody else got this? All right, here we go, type it in together, here we go. Parentheses, 1 plus 0.0788 divided by 4, close parentheses, raised to the 80th, minus 1 equals, divided by parentheses, 0.0788 divided by 4, close parentheses, equals, times 500. That's right, so that's what you need to get. And again, if you type, with the exception of this, if you type exactly what's written there, you will get the right answer. So if you're putting in extra parentheses or hitting equals in places you shouldn't, it won't work. But if you type parentheses, 1 plus this, parentheses, 2 to 80th minus 1 equals, divided by parentheses, this equals, times 500, you'll get the right answer. I promise. If you're not getting that, that would be something to do during office hours or with a friend or something. We gotta move on. Number 11, we got a house mortgage payment now. Mortgage payment. That tells me I'm FV or PV. A mortgage is a house loan, so this is PV. Here we go. A 30-year, what is that, 86,000? So the loan is 86,000. What are her monthly payments? So here's another one, I'm solving for R. My interest rate is 0.0875. My payments are monthly. Oops, yeah. How many am I making? 30 years worth. But I'm making them every month, so negative 360. So take a look at that, make sure you understand first of all why I'm using this formula. I'm paying something off. It's presently valued at 86,000. All of these numbers make sense to everybody?
Where did you get the 360 from?
This is the total number of payments that are being made. I'm making monthly payments for 30 years. 30 times 12. Okay. All right, so let's type it in. This is another one where to get our answer, we're gonna have to do a division. But first I'm gonna figure out what that is. 1 minus parentheses, 1 plus 0.0875 divided by 12, close parentheses, raised to the negative 3/60th, equals, divided by parentheses, 0.0875 divided by 12, equals, and then 86,000 divided by that number. Anybody get 676.56? Beautiful, beautiful, beautiful. Number 12. Which formula for problem number 12? This tricks us all the time. It's not FD. Is she making payments every month? No, she's going down to the bank, handing them whatever, $8,000. And she's not coming back until it's $16,000. Guys, do you see the difference? She's not making a payment every month. Okay, so which formula? It is not these are payment formulas. It's one of those. Which one of those? Compounded monthly.
It's not per.
It's not per. So this one. So this is our formula. She invests 8,000, has a 9% interest rate, compounded monthly. How long will it take to get to 16,000? Question number 1, are we good with that formula choice? Question number 2, did I get all my numbers in the right spots? Then I gotta solve for T, which by the way is going to involve logarithms, right? Either ln or log, it makes no difference. Now, keep in mind that if you ln this problem, it is fine, either one's fine. You won't be canceling anything because you don't have an E. But you can ln absolutely fine, but not first. What do we have to do first? We gotta divide. So 2, this one works out nicely. 2 equals 1 plus 0.09 divided by 12 to the 12t. Now at this point, you gotta get this down. So at this point, we're either gonna log both sides or ln both sides. It makes 0 difference. Do whatever you're comfortable with. I went ahead and logged because I'm just a creature of habit. You can ln if you wish. So log 2 equals 12t log that parentheses. Now before you start typing away, your job is to get this by itself. So how are you going to do that? What are you going to need to do? What math are you going to need to do to get t all by itself? You're going to have to take whatever the log of 2 is and divide by 12 and divide by that guy. Don't we need to divide by both of them?
Yeah.
Okay, I like to do it separately. If you do it together, you have to make sure they're in parentheses. But I'm just going to take log 2. Speaking of parentheses, close it, log 2. And then I'm going to divide by 12. And that's going to give me something. And then I'm going to divide by log 1 plus 0.09 divided by 12. And I got 7.73 years. Anybody else?
Is it alright if we do log divided by log first, then divided by 12?
Absolutely. you have to divide by both of them.
Yeah.
Order doesn't matter, and you can do it together if you want. Just so we end up, everybody should get 7.73. Okay, see how I snuck that one in there? That is not an FV or PV. What word, one word, signals you that it's gonna be an FV or a PV? Lauren? No, because compounded can happen, actually with any of our formulas, they can have the word compounded in there. What word tells me I have an FV or a PV? Payment, payment. The minute you see payment, you know, making payments, whether you're saving or paying something off, if you're making payments, you're. All right, here we go, 13. What is Erica's monthly payment for a 3-year, $4,500 car loan with an interest rate of 10.25? You want it, Erica's got to pay her car off. PV. We're gonna PV this one. PV over here. We wanna know her payment, so we're solving for R again. The loan is $4,500, so this is the present value of the loan. Right now, she owes $4,500. The interest rate is 0.1025 divided by 12, because she's making monthly payments, right? What's my exponent? How many of these is she making? 36, so negative 36, remember negative in this formula, 0.1025 over 12. Does everyone understand why we PV'd? Everybody understand the setup? Then you're gonna figure out what this is and divide 4,500 by it. Let's see what you come up with. What'd you come up with? What's your payment amount? $145 and 73 cents? Is that what you got? First time I typed this in, I don't know what I did or didn't do, but I got like 18,000. Would that clue you in that you made a mistake?
Yes.
Yes. If the loan is only $4,500, I hope I'm not making $18,000 payments, right? So I had to retype. All right, 2 more, here we go. Amy contributes $50 per month. Amy contributes $50 per month. Payments? What's the value of Amy's investment after 25 years? This is FB. We're saving for the future. And we want to know what it is. Her payments are $50 a month. The interest rate is 0.0726. Doing it monthly. What's 25 times 12? 300. Any question about the setup, guys? Are we good with that? I got 42,211.46. Anybody else get that? You guys are wonderful. All right, quickly, let's get the last one set up. You can type it in on your own. Number 15, PV or FV? It's another FV, isn't it? Contributes $50 a month. So FV equals, 50. 1 plus 0.155 divided by 12. Exponent 240 this time. Is that all right? Did you get 80,367.73? No? Did anyone get that?
Yes.
Yes, okay, I'm gonna go with it then. That seemed like a lot to me at first, but that interest rate is huge. So 15% interest for 20 years. Homework's due on Monday? Did I already have that written down? So homework's due on Monday. And I'll have review sheets for you next time. We'll go over our quiz. We'll probably have another quiz that we'll practice for next time too.